Our solar system is a diverse place, teeming with a variety of celestial bodies that each tell their own unique story. It's filled with planets of different sizes, compositions, and temperatures, each one a world unto itself with distinct characteristics and mysteries waiting to be unraveled. Among them are Venus and Mercury, the two innermost planets, each offering a glimpse into the extremes of our cosmic neighborhood. These planets, though close to each other in the grand scheme of the solar system, present vastly different environments and conditions. While you might expect Mercury, the planet closest to the Sun, to be the hottest, the reality is far more intriguing. Despite its proximity to the Sun, Mercury's lack of a substantial atmosphere means it cannot retain heat, leading to drastic temperature fluctuations. Venus, the second planet from the Sun, holds that title. Its thick atmosphere, composed mainly of carbon dioxide, creates a runaway greenhouse effect, trapping heat and making it the hottest planet in our solar system. Its surface is hot enough to melt lead, a testament to the powerful forces that shape planetary climates. The intense heat and pressure on Venus's surface are beyond anything we experience on Earth. Mercury is a small rocky world, its surface heavily cratered and ancient. This planet, with its barren landscape, offers a window into the early history of our solar system. Imagine the moon, but bathed in the intense light and heat of the nearby sun. Mercury's lack of atmosphere means it experiences extreme temperature variations, from scorching heat during the day to freezing cold at night. This gives you a sense of Mercury's stark beauty. Its desolate, cratered surface is a testament to the harsh conditions it endures. Venus, on the other hand, is shrouded in thick clouds. These clouds are composed of sulfuric acid, making Venus's atmosphere not only thick but also highly toxic. These clouds obscure our view of its surface, making it difficult to study the planet directly. However, they also provide clues about the intense atmospheric conditions on Venus. They hint at the intense heat trapped beneath. The thick cloud cover acts like a blanket, keeping the surface of Venus incredibly hot. The story of these two planets is a story of contrasts. While Mercury is a world of extremes with its temperature swings, Venus is consistently hot due to its thick atmosphere. It's a reminder that distance from the Sun isn't the only factor that determines a planet's temperature. The composition and density of a planet's atmosphere play a crucial role in shaping its climate. The composition of a planet's atmosphere plays a crucial role. It can trap heat, reflect sunlight, and create weather patterns, all of which contribute to the planet's overall climate and habitability. Imagine Earth without its atmosphere. Picture a world where the sky is perpetually black, and the surface is exposed to the harshness of space. The sun's rays would beat down unfiltered, making the planet blisteringly hot during the day and frigidly cold at night. Without the protective shield of our atmosphere, life as we know it would be impossible. Our atmosphere, a delicate balance of gases, regulates Earth's temperature, making life possible. It acts as a blanket, keeping the planet warm enough to sustain life and protecting us from harmful solar radiation. Venus and Mercury each possess an atmosphere, but their atmospheres are vastly different from each other and from Earth's. However, they are vastly different in composition and thickness. These differences have profound effects on the conditions found on each planet. Venus boasts an incredibly dense atmosphere, composed primarily of carbon dioxide. This thick layer of gas creates a surface pressure 92 times greater than Earth's. This thick blanket of gas traps heat from the sun, creating a runaway greenhouse effect. The heat is unable to escape, leading to extreme surface temperatures. This process has resulted in a surface temperature that's hotter than any other planet in our solar system, reaching up to 900 degrees Fahrenheit, hot enough to melt lead. Mercury's atmosphere, in stark contrast, is incredibly thin. It's almost non-existent, composed of trace amounts of oxygen, sodium, hydrogen, helium, and potassium. Scientists call it an exosphere. This exosphere is so thin that it doesn't provide any significant protection or insulation. This thin atmosphere offers little to no protection from the sun's intense radiation or to trap any heat. As a result, temperatures on Mercury can swing dramatically, from scorching 800 degrees Fahrenheit during the day to a freezing minus 290 degrees Fahrenheit at night. The thickness of an atmosphere contributes directly to its atmospheric pressure. This is the force exerted by the weight of the atmosphere on the surface. On Earth, we experience a comfortable atmospheric pressure that allows us to breathe and live comfortably. Venus's thick atmosphere, however, creates an incredibly high surface pressure. It's about 90 times greater than Earth's. To experience this on Earth, you would have to dive more than half a mile beneath the ocean's surface. This crushing pressure is one of the many challenges that make Venus a hostile environment for exploration. Mercury's nearly non-existent atmosphere results in a surface pressure that is almost a perfect vacuum. It's millions of times less than Earth's. This means that sound cannot travel on Mercury and there is no wind to speak of. Venus is often called Earth's evil twin. This is due in part to its scorching surface temperatures, which average around 900 degrees Fahrenheit or 475 degrees Celsius. This intense heat is a direct result of the runaway greenhouse effect created by its thick carbon dioxide atmosphere. Imagine a furnace that's constantly burning day and night. That's what it's like on the surface of Venus. The heat is so intense that it would melt lead, and spacecraft that have landed there have only survived for a few hours before succumbing to the extreme conditions. Section 5. Mercury's extreme temperature swings. Mercury, despite being the closest planet to the Sun, experiences wild temperature swings. This is because its thin atmosphere provides no insulation. During the day, temperatures can soar to 800 degrees Fahrenheit or 430 degrees Celsius as the sun's rays beat down relentlessly. However, without an atmosphere to trap the heat, nighttime temperatures on Mercury plummet to minus 290 degrees Fahrenheit or minus 180 degrees Celsius. This extreme temperature difference between day and night makes Mercury a place of stark contrasts. Section 6. Reflecting on albedo. Albedo is a measure of how much light a planet reflects. It is a crucial factor in understanding the energy balance of planets and their climates. A higher albedo means that a planet reflects more sunlight and therefore absorbs less heat. This can significantly affect the planet's temperature and weather patterns. Imagine wearing a white shirt on a sunny day. The white shirt would reflect the sunlight, keeping you cooler than if you were wearing a black shirt, which would absorb more sunlight. This simple analogy helps us understand how albedo works on a planetary scale. Just as the white shirt reflects sunlight, a planet with a high albedo reflects more solar energy. Venus has a very high albedo because its thick clouds are very reflective. These clouds are composed mainly of sulfuric acid, which is highly reflective. They reflect about 75% of the sunlight that hits them. This high reflectivity means that only a small fraction of sunlight penetrates through to the surface. This means that less sunlight reaches the surface to be absorbed and turned into heat. Despite this, Venus is still incredibly hot. However, the thick atmosphere traps the heat that does reach the surface, making Venus incredibly hot. This is due to the greenhouse effect, where gases in the atmosphere trap heat. Mercury, on the other hand, has a very dark, rocky surface, giving it a very low albedo. Its surface is covered in dark basaltic rock. It absorbs about 90% of the sunlight that hits it. This high absorption rate means that Mercury's surface heats up quickly. This contributes to the extreme heat it experiences during the day. Temperatures on Mercury can soar to over 400 degrees Celsius during the daytime. Understanding albedo helps scientists predict climate patterns and energy balances on different planets. It is a key factor in the study of planetary science and climate change. On Earth, albedo plays a significant role in regulating our climate. Factors like ice caps, clouds, and even human activities can influence Earth's albedo. Changes in Earth's albedo, such as melting ice caps or deforestation, can have profound impacts on global temperatures and climate patterns. By studying albedo, scientists can better understand and predict changes in our climate, helping us to prepare for and mitigate the effects of climate change. As we continue to explore our solar system, understanding albedo will remain a crucial part of our quest to understand the diverse worlds that share our sun. Section 7. The Sun's Influence, a matter of distance. Distance from the Sun plays a crucial role in a planet's temperature. The closer a planet is to the Sun, the more intense the solar radiation it receives. This is why you might assume that Mercury, being the closest planet to the Sun, would be the hottest. While Mercury does receive significantly more solar radiation than Venus, its lack of a substantial atmosphere prevents it from retaining any of that heat. Venus, despite being farther away, compensates for its greater distance with its thick, heat-trapping atmosphere. Section 8. The runaway greenhouse effect, Venus's heat trap. The runaway greenhouse effect is a process that has dramatically shaped Venus's climate. It's a cautionary tale of how atmospheric composition can have a profound impact on a planet's temperature. Venus's atmosphere, primarily composed of carbon dioxide, traps heat from the Sun. As the planet absorbed more heat, its temperature rose. This in turn caused more carbon dioxide to be released from rocks and surface materials, further thickening the atmosphere and trapping even more heat. This cycle created a feedback loop that led to the extreme temperatures we see today. Section 9 Conclusion: Venus's surprising heat. In the cosmic dance of our solar system, Venus stands as a testament to the power of the greenhouse effect. Despite being farther from the Sun than Mercury, its thick carbon dioxide atmosphere has turned it into a hothouse planet, with surface temperatures hot enough to melt lead. This surprising truth underscores the importance of atmospheric composition in shaping a planet's climate. It serves as a reminder that distance from a star is just one piece of the puzzle when understanding the diverse range of planetary environments in our universe.